Good morning, students. Welcome to our last session for our review in mathematics. This is our session number 6. Our topic for today is about quadratic functions. Our objective at the end of the session, the learner should be able to, number 1, illustrate quadratic equations in general form and standard form. Number 2, solve quadratic equations by factoring and zeros of polynomials. Here is the general form of a quadratic function. F of x is equal to ax squared plus bx plus c, while the standard form of a quadratic function is f of x is equal to a times x minus h raised to the second power plus k. So what is a polynomial? It is come from the word poly, means many, and nomial meaning terms. Therefore, we all know that polynomial has so many terms. We have 1 term, 2 terms, 3 terms, and more. So a polynomial function, it is a function such as a quadratic, a cubic, a quartic, and so on, involving only non-negative integer powers of x. When we say quadratic, the power of the polynomial function is raised to the second power. A cubic, the power is raised to the third power, and a quartic is raised to the fourth power. Example, we have 3 examples here. The lower part, we have the f of x is equal to 5. We have only one term, the constant. It is called monomial. The middle example, the f of x is equal to 3x minus 5. We have 2 terms, and it is separated by the fundamental operation of subtraction. So if we have 2 terms, it is called binomial. And the first example, f of x is equal to 4x squared plus 3x minus 5. We have 3 terms. So it means it is called trinomial. How about zeros of a polynomial? These are the values of x that cause the polynomial equals to 0 or make the equation y is equal to 0. That's why we are going to equate the said equation or the factor of the equation into 0 in order to get the root. So the root is the x value and the 0 is the y value. So example number 1, we have the function f of x is equal to x squared minus 9x plus 20. The factor of the given function is equal to x minus 5 times x minus 4. So let us check. When we multiply x times x, we have x squared. And when we add negative 5x plus negative 4x, we have negative 9x. Then when we multiply negative 5 times negative 4, we have positive 20. Therefore, it is correct. Then we are going to equate the said factors into 0. The first factor is x minus 5 is equal to 0 and x minus 4 is equal to 0. Therefore, we transpose or we transfer the constant to the other side, so the sign will change, so it is x is equal to 5. And the other one is x is equal to 4. Then we are going to check. So when we check, we are going to use the original equation or function that we equate into 0. Let us check if it will equal to 0 when we use the value of the x. Okay, let's start with the x is equal to 5. So therefore, the 5 raised to the second power is equal to 25 minus 9 times 5, we have 45 plus 20. Okay, the difference between 25 minus 45 is equal to negative 20 plus 20 is equal to 0. Therefore, the value of x, which is 5, is the correct value for that equation. So how about if x is equal to 4? Okay, the squared of 4 is equal to 16. Minus 9 times 4, we have 36 plus 20. Okay, the difference between 16 minus 36 is equal to negative 20. Plus 20 is equal to 0. Therefore, both the value of x, which is 5 and 4, is a correct values of x for that given equation or function. Example number 2. We have the function f of x is equal to x squared plus 4x minus 21. The factor of the given function is equal to x plus 7 times x minus 3. Okay, let us check. When you multiply x times x, we have x squared. When we add 7x plus negative 3x, we have positive 4x because 7 is bigger than 3. So when we multiply 7 times negative 3, we have negative 21. Okay, let's proceed. Equate to 0 the given factors. So x plus 7 is equal to 0 and x minus 3 is equal to 0. Therefore, x is equal to negative 7 and the other one is x is equal to 3. Okay, let us check. We're going to use first the value of x, which is negative 7. Okay, the square root of negative 7 is equal to 49 plus 4 times negative 7 is equal to negative 28 minus 21. So 49 minus 28, we have positive 21 minus 21 is equal to 0. Therefore, negative 7 is correct. How about the value of x is equal to 3? The square root of 3 is equal to 9 plus 4 times 3, we have positive 12 minus 21. When we add 9 plus 12, we have positive 21 minus 21 is equal to 0. Therefore, both the value of x, which is negative 7 and 3, are the correct values for the given equation or function. Example number 3. The function f of x is equal to x squared plus 10x plus 16. The factors are the following: x plus 2 times x plus 8. Okay, let us check. X times x, we have x squared. And the sum of 2x plus 8x is equal to 10x. And then the product of 2 times 8 is equal to 16. Okay, let's equate to 0. X plus 2 is equal to 0. And x plus 8 is equal to 0. Okay, therefore, the value of x is equal to negative 2, and the other one is x is negative 8. Okay, let's use first the value of x, which is negative 2. The square root of negative 2 is equal to 4. Plus 10 times negative 2, we have negative 20 plus 16. The difference between 4 minus 20 is equal to negative 16. Plus 16 is equal to 0. So that is correct. How about negative 8? The square root of negative 8 is equal to positive 64. Plus 10 times negative 8, we have negative 80 plus 16. The difference between 64 minus 80 is equal to negative 16. Plus 16 is equal to 0. Therefore, the value of x, which is negative 2 and negative 8, is the correct value for the given function or equation. Okay, how about rational function? It is a function that is a fraction and has the property that both its numerator and denominator are polynomials. It could be monomial, binomial, trinomial, and polynomial. Okay, in the given example, p of x is equal to x squared plus 5 over x plus 2. If you still remember with the derivative of the quotient rule, we use this kind of rational function that the numerator is our f of x and the denominator is our g of x. But this time, we're going to apply the factoring method and equating the factors to 0, and we are going to check if the given function, when we equate to 0, is the root or the value of x is correct. Okay, as I've said, p of x is a rational function if p of x is equal to function of x in the numerator and a function of g of x in the denominator, meaning two functions, the ratio or the fraction of two functions. Example, p of x is equal to x squared plus 2x minus 8. And the factor of this equation or function is x minus 2 times x plus 4. While the denominator is x squared plus x minus 12, and the factor is x minus 3 times x plus 4. We eliminate x plus 4, then we have the remaining x minus 2 over x minus 3. Take note, students, the denominator could not be equal to 0. Why? It will equal to undefined. So therefore, we have a condition here that the denominator is x should not equal to 3. Okay, let us equate the numerator to 0. So x minus 2 is equal to 0. Therefore, x is equal to positive 2. Let us check. We are going to use the value of x, which is equal to 2. If the given p of x will equal to 0, let us check if the value of x is correct. So the square root of 2, we have 4 plus 2 times 2, we have 4 minus 8. While in the denominator, the square root of 2 is equal to 4 plus 2 minus 12. Okay, 4 plus 4, we have 8 minus 8 is equal to 0. While in the denominator, 4 plus 2, we have 6 minus 12, we have negative 6. Okay, 0 over a number, positive or negative, it is equal to 0. While a number over 0 is undefined. So therefore, the value of x, which is equal to 2, is the correct value for our function or equation. So that's all for today, students. Thank you for watching. I hope you learned from this lesson. Please ready for a short assessment.